Alright people, pay attention to this. A leak from Weibo, a Chinese social media platform, indicates that TSMC and Apple would be collaborating once more on creation of an AI server CPU. You heard correctly. Rumor has it that a Weibo user has disclosed Apple's next step into the AI tool market. He asserts that TSMC's cutting-edge 3nm node will be used to create the CPU. Apple recently released a number of huge language models that are meant to run on devices rather than on cloud servers, which only serve to fan the flames. OpenELM is distinguished as the most advanced open language model among them. Even though Apple is renowned for withholding project details until they're ready, the news that OpenELM is prepared to completely transform the way we live was unexpected. But will that actually be the case? Let's examine what makes OpenELM so fascinating. Thus, this model's technological capabilities as well as its openness make it intriguing. To more accurately distribute parameters among the layers of the transformer model, it uses a layer-wise scaling mechanism. To put it simply, this method ensures that no one component of the system is overloaded while each layer of the model has exactly the proper quantity of data required for efficient operation. This improves the accuracy and efficiency of the model as a whole, improving its capacity to comprehend and produce language. It's interesting to note that OpenELM is supposed to achieve 2.36% higher reliability with half as many pre-training tokens than its predecessor model. All in all, let's now briefly discuss training. Billions of data points from various public sources, such as articles from GitHub, Wikipedia, Stack Exchange, and other sources, were used to train the model. With a maximum context window of 2048 tokens, this model can understand and write text at a human level based on the input it gets thanks to its extensive training. A comprehensive set of tools and frameworks for further testing and training are also included. Moreover, Apple's decision to provide an open-source platform for model assessment and training is notable. Typically, companies just supply the programs needed to run the model weights. By offering training records, several checkpoints, and comprehensive pre-training preparations, OpenELM goes above and beyond. In light of the recent legal troubles that companies like Microsoft, OpenAI, and Amazon have encountered due to their AI training practices, how do you feel about Apple's approach to transparency? Tell me in the comments, people. Nevertheless, OpenELM uses a few cunning tricks as well to make the most of its hardware. For example, despite using fewer pre-training tokens than other models like OpenELM, it is more accurate than other language models. It accomplishes this by using clever strategies to preserve equilibrium and improve the model's performance in benchmark testing, such as grouped query attention and openness norm. Grouped query attention makes it easier for the AI to focus on the most crucial portions of the data, which improves its comprehension of the information it is processing. By ensuring that updates during training are even in balance, preventing any one component from becoming overly dominating, and maintain performance consistency, the openness norm technique maintains AI learning steady. Now, let me take a moment to ask you all to support the channel and make sure you don't miss the next AI news by subscribing to the channel and liking the videos if you think I'm doing a good job with them. Now, several common zero-shot and few-shot tasks show how successful the model is, with OpenELM routinely outperforming other models. Knowing how effectively these kinds of AI models work in real life is important for understanding how they are used there. For this reason, benchmarking is crucial. These exercises evaluate the model's comprehension and reaction to typical situations for which it hasn't received any special training. Additionally, Apple has ensured that OpenELM functions flawlessly on a variety of systems, including those with Apple-branded CPUs, Linux, and CUDA-capable computers. It merely demonstrates how adeptly this model can bend and adjust to various configurations. We may now ask how it stacks up against other models of its kind. Experiments have indicated that this model outperforms other models of a similar nature, such as OpenELM, but because it verifies its computations using complex approaches like openness norm, it performs a little bit slower. In order to ensure that the model functions in a variety of scenarios, it was also tested on a variety of hardware configurations. Apple's strategy for ensuring that its software functions well with the newest hardware is, I suppose, demonstrated by OpenELM running on Apple's M2 Max chip, I suppose this chip uses float 16 precision and lazy evaluation to make sure the system handles data efficiently. Programming's notion of lazy evaluation holds that expressions should not be evaluated until after the results are required. This can increase the system's efficiency by reducing the needless computations. But what else is this approach likely to offer? Yes, there are plenty more. The element management system in OpenELM is highly tuned. By manually adjusting each component of the model, the computing power that is available can be utilized to its fullest. This improves accuracy and makes the model more effective in a variety of AI tasks. This is because during the testing phase of OpenELM, Apple discovered that while the system generated accurate findings, the return time was very slow. The business is attempting to address this problem and speed up the process without sacrificing accuracy. Ultimately, I believe it is more significant to provide accurate responses after pausing for thought as opposed to making erroneous assertions in a matter of seconds. People, you should know that Apple tests OpenELM in a number of ways. Every kind of knowledge, from easy can-do tasks to challenging critical thinking tasks, has been included in the assessments. The purpose of this test was to evaluate OpenELM's performance across several knowledge domains. When it came time for the compatibility test, Apple needed to confirm that its LM model coordinated with its own gadgets. In order to find out how well OpenELM performed with Apple's MLS framework, which enables machine learning programs to run directly on Apple devices, an additional test was conducted. If it performs well, I suppose there will be less demand for cloud-based services and user data will be kept more private. Additionally, developers can utilize the code to operate with the MLX library since Apple published it to OpenELM. This makes it easier for developers to integrate the LLM without requiring an internet connection into their existing systems. You may argue that Apple wants to provide developers the flexibility to modify and integrate OpenELM into their apps. Because of this, the company produces models that have been trained on publicly accessible datasets. Additionally, models with varying parameter sizes are made available. Apple's dedication to on-device artificial intelligence processing, in my opinion, is a sign of a broader trend in the industry that emphasizes consumer privacy and safety through localized computing. Furthermore, I suppose OpenELM may alter the way people engage with Apple products such as MacBooks, iPads, and iPhones. But what are your thoughts, people? In any case, using AI models directly on your phone and other odd devices has the potential to revolutionize the industry. As you may know, when devices handle data locally, they react more quickly and protect user privacy, two things that are extremely crucial in today's world. Apple's WWDC conference coming up soon. I genuinely believe that OpenELM's launch is just another clue that signals iOS 18 might have AI capabilities.